Okay, I want you to imagine something with me. Picture opening an app, maybe like a Google Maps for the cosmos. But instead of typing in a street address, you type in coordinates for a solar system, say 10 times billion light years away. You pinch the screen, and just like that, you're zooming past our own Milky Way, flying through these vast, dark voids of space until you lock on to a small, purple, rocky exoplanet. You keep zooming, right down through its atmosphere, over these alien oceans, and you land on a single mountain peak, so close you can see a tiny microscopic crack on one of the rocks. But here's the truly incredible part.
That crack, it isn't a gas, it's not some artist's rendering. It is a mathematical certainty. And what I'm describing, it's not science fiction. This is a legitimate blueprint for what could be the single greatest undertaking in all of human history, and one we could actually achieve in our lifetime. A perfect, one-to-one scale, real-time map of the entire universe.
So, how in the world do we get there? Well, first, we're going to define just how massive this endeavor is. Then, we'll break down the two huge cosmic barriers standing in our way. After that, we're going to explore the three revolutionary pillars that make this possible: an invisible skeleton, a virus of curiosity, and a wild way to literally reverse engineer reality itself. And it all leads to us holding the entire cosmos right in the palm of our hand. To put it as simply as possible, the goal here is to build a perfect digital twin of the entire universe, a one-to-one scale map that is accurate right down to the atomic level. This is the story of how we map the infinite.
Now, before we can even begin, we first have to wrap our heads around, and then overcome, two fundamental problems with the cosmos itself. And these aren't just engineering challenges, these are barriers that are baked right into the very fabric of reality.
The first problem, it's the sheer, terrifying scale of it all. The observable universe is 93 billion light-years across. It's got trillions of galaxies, and each of those has hundreds of billions of stars. The number of planets, it's just completely unfathomable. Seriously, the scale alone is enough to break your brain.
And that scale leads us to our second and, honestly, more difficult problem. Because light travels at a set speed, we're always looking into the past. The light from a really distant galaxy could be billions of years old. That means the object we're seeing, it might not even exist anymore. So that raises a huge question. How can you possibly map something in real time when the universe is constantly showing you a ghost?
Well, the answer lies not in what we can see, but in what we can feel through the force of gravity. Our first pillar is to map something that holds the entire cosmos together, yet remains completely invisible to us: the dark matter web.
You know, for decades, astronomers have realized that galaxies are spinning way too fast. Based on all the stars and gas we can see, they should just fly apart. Something invisible, something absolutely massive, has to be holding it all together. And that something is dark matter. It makes up a whopping 85% of all the gravity in the universe.
So think of this dark matter as a vast cosmic highway system. It has these giant, invisible threads that connect every single galaxy. By measuring the gravitational pull along these filaments, we can instantly figure out the exact location and trajectory of every major galaxy. We completely bypass the speed of light problem. We map the invisible, and the visible just falls right into place.
Okay, so that gives us our galactic roadmap. But what about all the details? How do we map the individual planets and moons and all the rocks in between? For that, we need to get up close. And our second pillar involves unleashing an unstoppable, self-replicating swarm to basically act as our eyes and hands all across the cosmos. We're going to do this using something called a von Neumann probe. Just imagine a little spacecraft, maybe the size of a toaster, packed with an advanced AI and some basic 3D printing gear. The amazing part is, we only need to build and launch one of them. Just one.
The process is just brutally simple and effective. It lands on an asteroid, it mines raw materials like iron and silicon, and then it prints an exact copy of itself. Now there are 2. They fly to 2 more asteroids. Now there are 4. Then 8, 16, 32. You see where this is going. This exponential growth is the absolute key.
In a surprisingly short amount of time, you'd have a swarm of trillions of these intelligent drones just spreading out from Earth like a shockwave. It's truly an unstoppable physical virus of human curiosity. They'll enter every star system, map every planet, and then beam that data back to us instantly using quantum entanglement. That's the spooky phenomenon where linked particles can communicate with each other over any distance with zero delay.
But look, even with trillions of drones, physically scanning every single inch of every single planet would still take way too long. And this brings us to the third, and honestly the most mind-bending pillar of this whole plan. We don't have to scan everything. We just have to reverse engineer reality itself. The key insight here, the big idea, is that the universe isn't random at all. It's a system that's governed by strict, unbreakable rules. Water always freezes at a certain temperature. Carbon always bonds in very specific ways. See, the formation of a planet, it's not a creative act. It's a chemical equation playing out over billions of years. So our probes, they don't actually need to scan an entire world. They just need to gather a few key data points. Its mass, its chemical composition, its distance from its star, that kind of thing. They feed that data to a massive quantum AI back here on Earth, which can then simulate that planet's entire multi-billion-year history, every volcanic eruption, every continental drift, all of it, in just a matter of seconds.
What the AI spits out is a 3D model that is 99.99% identical to the real thing, which means that crack on the rock from the very beginning, it's not a guess. It is the only possible mathematical outcome based on that planet's fundamental physics and chemistry.
And this is where everything just clicks into place. By combining these three revolutionary technologies, we finally achieved the ultimate goal, a perfect, real-time digital twin of our entire cosmos.
So let's recap. We use the gravitational map of the dark matter web for all the big macro-scale locations. We use the von Neumann probe swarm for the up-close, micro-scale data collection. And then we feed all of that into a reality-simulating quantum AI to fill in every single detail with mathematical perfection. The result is, well, it's nothing short of breathtaking. You could put on a headset and walk on the surface of a world a billion light years away, and you would know that the alien dirt beneath your digital feet is exactly what's out there in the dark. We will have shrunk the infinite down to something we can hold, something we can explore, and finally, something we can understand. This leaves us with a pretty profound final thought. For all of human history, we have looked up at the stars in wonder. This technology would transform that wonder into knowledge, and it would turn that deep mystery into a tangible place. So the real question is this: what happens to us? What does humanity become when the infinite is no longer a mystery, but is simply a destination on our map?